Hi, I'm Neil Feit of the SUNY Fredonia Department of Philosophy. Today I'm going to do some proofs in statement logic. I'm going to be using the Power of Logic web tutor. I'm using the 4th edition. 5th edition is similar. And I encourage you to have rules at your disposal to look along with me here. And of course, to pause the video at any point if you want. I'm going to do a few proofs. I'm going to do a proof from exercise 8.1. And by the way, this video will supplement chapter 8, sections 8.1 and 8.2 of the Power of Logic textbook. And I'm going to scroll down here. Here in the exercise 8.1 proofs, we have a bunch of valid arguments, and we have 8 rules at our disposal, the implicational rules. And I'm going to scroll down to number 11 and select that one. Okay. I'm going to click in the box here. Okay. This is a relatively simple proof. I'm not going to spend too much time on it. If you want to make a wish list, and I'm not going to write out a wish list here, but I can give you a little bit of a hand at doing that. Okay, obviously the conclusion, F, that's going to go on your wish list, okay? And you might be thinking, well, what do I need to get F, okay? Well, you might look at not E in premise 4, okay? So if you had E or F with not E by disjunctive syllogism, you could get F. So I would put E or F on my wish list, okay? Having said that, B then D should go on the wish list, because if you have B then D, you could use modus ponens with line 3 to get E or F. Okay. At this point, you might be thinking, how can I get B then D? Okay, which is a good thing to think about. If you look at premises 1 and 2, and the rule of hypothetical syllogism, they entail B then D by hypothetical syllogism. So we can follow those logical breadcrumbs back home by first getting B then D from lines 1 and 2, and then crossing off the items from our so-called wish list as we go along. Okay, so we have 4 premises. The next line is 5. Okay. Again, I'm looking at premise 2. It says if B then R. Now premise 1 says if R then D. So by hypothetical syllogism, we get B then D. Okay, I'm doing shift greater than to get an arrow. Okay, and this is going to be 1, 2. HS, hypothetical syllogism. By the way, the system accepts 2, 1 as well. You don't have to go in increasing numerical order. That's a personal preference of mine. And for statement letters, B and D in this case, in line 5, they have to be uppercase. But for the rule, the annotation of the rule, they don't have to be uppercase if you don't want to, and the system will turn them into uppercase if you check the proof. Okay. Notice now lines 3 and 5 have modus ponens form. We could get E or F, lowercase v for disjunction. Okay, that's going to be 3, 5 modus ponens. I'll leave that lowercase. By the way, I'll check the proof now. Okay, it says that the 2 lines that I've done, lines 5 and 6, are correct with the green check marks. But I keyed in line 7, but I didn't enter anything there. So if I hadn't even keyed in line 7, it would have said the proof is incomplete. Okay, so I'm going to go on. Okay. Well, lines 4 and 6 now have disjunctive syllogism form to give me my conclusion, F. Okay, 4, 6 ds. Okay. It tells me all the lines that I've entered are correct, green check marks, and it says, congratulations, no errors were found in the proof. Okay, now that's a relatively easy proof. I'm going to do one more, a slightly tougher proof from exercise 8.1d. Again, only the 8 implicational rules of inference are at our disposal here. I'm going to scroll down to number 20. Okay, here's the argument. Okay, it's a valid argument, and we're told to construct a proof. Okay, again, this happens to have 4 premises, so the next line is going to be line 5. Okay, so if we were doing a wish list here, I would put not R on it. Obviously, that's what I want to prove. That's my conclusion. If I look up in premise 1, okay, I could see that the dot, by the way, of premise 1 is the main operator there. So I could simplify out not L, then not R. Okay, so I might want to put that on my wish list explicitly. Okay. Now, at this point, I might just want to put not L on my wish list, because if I have not L together with that other line that I underlined, not L then R, I would get the main conclusion, not R. Okay. Well, how might I get not L? Well, scanning the premises, I see that I could simplify this side of the conjunction of premise 2, not N then not L. Okay. So I might also want to, in addition to not N then not L, I might want to put not N on my wish list. Okay. How could I get not N? Alrighty. Well, if I have not Q, which I could put on my wish list, I could get S or not N, okay? Which means by disjunctive syllogism, if I had not S, okay, if I had not S all by itself, I could get to not N. Alrighty? Well, I might then put S then C on my wish list, because if I had not C, by modus tollens there, I could get not S. Okay, well look, I already have not Q here, so if I put C then Q on my wish list with not Q, I could get my not C. Okay. Again, the wish list strategy might or might not be helpful to you, but I kind of figured out how we're going to do this proof by sort of working backwards from the conclusion and what we need to get to the conclusion, what we need to get to what we need, and so on. Okay, I'm going to erase my wish list here. Okay, and try to remember those logical breadcrumbs. Okay, well, let's see. I think from the reasoning that I just employed, I'm going to have to simplify everything from lines 1 and lines 2. Okay, so let me take the C, then Q. Okay, and that's going to be 1 simp. Okay. And maybe I'll also do a 1 simp. I'll get the not L, then not R. That's also, oops. That's also going to be a 1 simp. Okay. Again, the main operator of line 1 is the dot, so we could simplify. We could use the rule of simplification. Let me do the same thing with line 2, because I think from the reasoning that I was talking about with the wish list, we're going to need both conjuncts of line 2. So here's the left conjunct, 2 simp, and not N then not L is the right conjunct of line 2. So that's also 2 simp. Okay. For line 3, I wanted to simplify the not Q. Okay. So that's a 3 simp. Simplifying conjunctions, by the way, is a good thing to do a lot of the time. So it's a good, you can't go wrong if you simplify a conjunction. Okay. And the J from premise 3, I don't think we're going to need. So I could simplify that. The extra step is not incorrect by any means, but it's not necessary to doing the proof. Okay. If I look at what I have on line 9, I see that it's the antecedent of line 4. Line 4 is a conditional whose antecedent is not Q. Well, that's on line 9. So I could use modus ponens with 4 and 9 to get S or not N. And again, that's 4 comma 9, MP, modus ponens. Okay. So now I kind of want to get not S, okay? Well, look at line 9 again, and look at line 5, okay? They have modus tollens form. Line 5 says if C then Q, but line 9 says not Q. So they give us not C, and that's a 5 comma 9 modus tollens. Got my moto running, okay? Now, with line 11 and line 7, if I look back up on line 7, okay, they also have modus tollens form. They give me not S. Kind of following my logical breadcrumbs back home. So that's a 7 comma 11 modus tollens. Okay, that's what I need to hook up with line 10. Okay, line 10 is a disjunction, S or not N. Line 12 says not S, so by disjunctive syllogism, that gives me not N, and that's going to be what? 10, 12, 10, comma 12 ds. Okay. Why did I want not N? Well, if you wrote down that wish list, or perhaps remember it, I want not N to get not L. So if you look up to line 8, which I simplified from line 2, line 8, line 8 and line 13 have modus ponens form. They give us not L. So 8, comma 13 modus ponens. Okay. And finally, I'm able to derive the conclusion. Okay, I wanted not L to get not R, and I simplified line 6 out to do that. So line 6 is now a conditional. Line 14 is the antecedent of that conditional. So by modus ponens, I could get not R. Okay, so it's, what did I say? 6, 14 modus ponens. Okay. So I think we have a proof here. The last step is the conclusion, and I think we've followed all the rules. We've annotated all lines that are not premises. Let's check the proof. Okay. And luckily it says no errors were found in the proof, so we have a proof. Now that's a 15-step proof, not such a long proof. This is a proof where simplifying conjunctions, which is a good general tip, is important, and the wish list strategy, or you might call it the working backwards strategy, is a good way to do things. I'm going to go to some 8.2 exercises, and again, I can't do anywhere near all of the exercises. By the way, I do strongly recommend the A and B, parts A and part B, annotating proofs, correct or incorrect, for practice in what's an instance of a rule versus what's not an instance of a rule. But here I'm going to just be doing some proofs, and I'm only going to do one more here. I'm going to do a longer one from 8.2. I'm going to do 8.2d, and I'm going to go down to number 20. Okay. There's lots of different sorts of valid arguments out there in statement logic, and the strategies for doing proofs of them are going to differ substantially. So again, I can't talk about all the different types of proofs and types of strategy, but I'll say a few words about this one. Okay. Notice here that the conclusion is a disjunction, not J or not H. Okay. And notice that if you scan the premises, you don't see not J anywhere, or J for that matter. Okay, J does not appear anywhere in the premises. That's going to give you a good hint that you're going to want to, so I just put the conclusion on my wish list. Okay, I'm going to want to get H and use the rule of addition to get not J or H. Okay, if I have any statement whatsoever, like H, I could use addition to say anything or H. Okay, and that's a valid inference. Take a look at the addition rule, one of the addition rules. The right addition rule. Okay, so I'm going to want to get H and use addition to get to my conclusion. Okay, well, how am I going to get H? Well, if I look at line 1, if I had not G, that would give me H. Okay, by disjunctive syllogism. Alrighty. Well, how am I going to get not G? Well, that's interesting. If I had not F or G, in other words, if I had the negation of this, okay, if I had not F, oops, parenthesis there is important actually, or G. Okay, that would get me not G. And by the way, I'm here in 8.2 where we have equivalence rules at our disposal. We have 5 of the 10 equivalence rules that we're eventually going to have: double negation, commutation, association, De Morgan's laws, and contraposition. And if you look at the De Morgan's rule, the lower De Morgan's rule in the left to right direction, not F or G is basically saying neither F nor G. So that's equivalent to not F and not G. Okay? And again, the equivalence rules are different from the implicational rules. They work both ways. You can use them in the left to right direction and the right to left direction. And they're called equivalence rules because each rule is a pair of logically equivalent statements. Remember that notion? Logically equivalent statements. And basically, these rules say that you could substitute one logically equivalent statement for another anywhere. So these rules don't have to apply to main operators, unlike the implicational rules. So there's two differences between equivalence rules and implicational rules. They go left to right and right to left. They're kind of horizontal in a way. And the operators that you see in the rules, they don't really have to be. They don't have to be main operators. Okay? So what I'm saying here is I'm going to add this to my wish list. Okay? Because that's going to give me not G by De Morgan's. How do I get that on my wish list? Well, I'm going to use line 3 and modus tollens. So I'm going to get the negation of the consequent of line 3 on my wish list. Okay. How am I going to do that? Well, I'm going to manipulate line 2. I'm going to basically take the contrapositive of what's in the parentheses of line 2. Okay, so you might pause and think about that for a little while, but I'm going to erase my wish list material here and kind of get going. Okay, from the get-go. So again, I want to prove H. Okay, and basically what I want to do is manipulate line 2. So here's what I'm going to do. I'm going to bring down that tilde, and I'm going to bring down the parentheses. Okay, the tilde is the main operator of line 2, but I could use equivalence rules on a portion of a formula that's smaller than the main operator. So the operators in the rules don't have to be main operators. So what I'm going to do is I'm going to use the contraposition rule on what's inside the parentheses in premise 2. Okay, and I'm going in the left to right direction. I'm basically going to take the contrapositive. So not D then E is equivalent to if not E. Okay, then, well, basically I need the negation of not D, so that's going to be not D. Okay, and I'll delete maybe, I don't think it's necessary, but okay. So what I just did was two contrapositions, so CONT is our abbreviation for that. Okay, so in other words, just to explain maybe one more time, I'm basically letting not D be P and E be Q. So we have P then Q. So here we have not Q, then not P. Okay. Okay. Notice there's a very strong similarity between this and this. They're logically equivalent, and I could simply remove those two tildes by our double negation rule in line 4, and thereby get the negation of the consequent of premise 3. Okay, so that's what I'm going to do. I'm going to carry down my parenthesis, my tilde parenthesis, nutty. And basically, what I'm going to use is the double negation rule. I'm just going to get rid of those two tildes. I'm using the double negation rule just on the not D, not the main operators. It doesn't matter. Equivalence rules can be used on non-main operators. Okay, the double negation rule, and in the right to left direction, and that's 4dn. Okay. Notice now that lines 3 and 5 have modus tollens form. Line 3 is a conditional, line 5 is the negation of the consequent, so I could get not F or G, and that's 3, 5 modus tollens. Okay. By De Morgan's then, kind of following the breadcrumbs home, I get not F and not G. That's comes from line 6 only. Notice, and that's De Morgan's DEM. Okay. Notice I'm using both implicational rules and equivalence rules. We have all the rules at our disposal now. I'm going to simplify not G. I don't think I'm going to need not F, so that's a 7 simp. That was on my wish list, if you remember. Okay. That hooks up with line 1 and disjunctive syllogism to give us H. Okay. H or G together with not G give H, so that's a 1 and 8 ds. Okay. Now, H is a statement like P, and if you look at the addition rule, I could add Q or P. I could add anything in front. So let my Q be not J. Okay, and this is going to finish the proof with 9 addition. And I'm going to check it, and hopefully it'll be correct. Yes. Okay. So we did 3 proofs in this video. We can't do everything. I can't explain all tips and techniques, but I hope the video was helpful with respect to, number one, just doing proofs in this Power of Logic Web Tutor platform, and more generally with respect to the idea of doing a proof in statement logic.